Hey, this is John Smith with ExtraHop Networks again. Today I want to talk about acute threat intelligence and how to leverage the extensible platform that Revealx offers with acute threat intelligence. And what I mean by that is we have some customers that have either something like recorded future, threat quotient, something like that, where they curate a list of campaign-related IOCs. And then what we want to do is make those readily available to the Revealx platform. So in this case, if you look at this diagram here, I'm working in the AWS Revealx attack lab. So we've built an attack lab in AWS where we're running some attacks. So here, what I'm going to do is I'm going to connect to, in this case, the open source version of Open Threat Exchange. So I'm going to connect to the AlienVault OTX Pulse for this particular Ioc. Special thanks to J.R. Reicherds. It appears as though this person set up a really nice pulse of COVID-19 related domains, or Ioc ransomware using COVID-19 domains. So what we're going to do is we're going to go out to OTX. We're going to grab those IOCs. And here, this is a Lambda function. This can be automated if you want. In this case, I'm going to do it manually. But I'm going to go out, I'm going to grab that pulse, all of the IOCs that are a part of it, and I'm going to basically import them into the session table on my Revealx system. And this will allow us to basically put, what the session table allows you to do is put around 32,000 instances that you can then reference, right? So it's memcache, where I can store things like IP addresses, domains, JA3 hashes. It's a little more flexible than our STIX threat intelligence, which is limited to domain, IP address, and URI. Here, within the session table, we can use any tuple, whether that's a user agent, a byte size, part of the payload, or a certificate issuer that might be nefarious, right? We can do all of these things, put those into the session table, and then as transactions occur, we can reference that session table to see if they're a part of that IOC or a part of that particular campaign. So let's let's check out what this is going to look like for us. So first thing we're going to do, here we've got a Jupyter notebook. So the first step is I'm going to go out to this pulse and I'm going to download these IOCs that are related to this pulse. Now here I'm going to grab just the URL, domain, host name, and IPs. But if there were other parts of that, we don't work with hashes on the wire. We work with JA3 hashes and that kind of stuff, but file hashes are really not something you do with an NDR solution. That's probably what you would use your EDR solution for. But here for the things like domain, URL, host name, IPv4, we're going to grab those indicators and then we're going to import them into our ExtraHop Revealx platform. So here I'm going to go ahead and grab this data, and there you see the outputs here. We have a myriad of host names, domains, we have some URLs, we have quite a bit of data in here. And then the next step, after we've basically grabbed that output dictionary, is we're going to upload it to our ExtraHop appliance that's in the AWS attack lab. So here you see these functions, here you see these tuples, these JSON blobs being basically imported into the Revealx platform. So if I come here, let's talk a little bit about what the trigger does. So the event I'm going to work with is called external data, right? So here, that's this event here. And what's going to happen is it's going to collect that data, and there you see the OTX intel is actually successfully being imported. So we're going to import this data and we're going to store it in memcache. And then what I've got, I wouldn't typically do this in the same trigger, but for this example, we're going to use this. If I get an HTTP request for a URI that's part of the threat intelligence campaign, I want to fire an alert and I want to tag the device. I'm tagging the device so that it has membership in this particular COVID threat, OTX COVID threat pulse, right? And so what I'm doing here is, as a device matches up with one of those IOCs, I want to be able to watch the campaign play out in an activity map here. And this will make sense in a minute once we start generating some IOCs. So the three events I'm going to look for are DNS request, HTTP request, then I've got a flow classify. So if it does any protocol that matches one of those IPs. So we have some IP addresses. So here I'm looking specifically at DNS names, and I'm looking at URIs. But if someone FTPs something to one of those IP addresses, then I want to know. I want to flag that, if that makes sense, right? So here, let's just take one of these domains, right? I'm going to copy this, and I'm just going to do a quick NS lookup. And let me just go to the bottom here, and I'll show you what that looks like. So here we have a couple of Kali boxes that are a part of the AWS attack lab. And so here I'm just going to do a DNS lookup, right? Or actually, let me try a wget. It may not be listening on this port, so we'll see. But I'm going to go there. Okay, I got a 403, but that's okay. I did get a transaction. So down here on the bottom, what you should eventually get is you should get two detections. You should get a DNS detection, and you should get an HTTP request detection, right? Because we did a lookup for this to resolve the name, and then the second part of it was it actually did the HTTP transaction as well. So we can do it also on this one as well. Let's go ahead, and I'm just going to find another one of these guys. Let's do this. Let me find here's a contain coronavirus.tech. So I'm going to go ahead and I'm just going to do an NS lookup on this one, right? So NS lookup there. I'm just going to look that up, right? And I should fire, and if you look here, you see we will fire on the DNS transaction as well as on the HTTP transaction. If you look here, you see that this device was tagged, right? Device 10 was tagged. So now if we come over here, you see this was blank. Now we see we have a device in here. And what this will allow you to do, there we have a second device, right? So there you see that second device was matched an IOC that's a part of this campaign. And then of course over here, we're watching the campaign play out in our enterprise. And as more and more devices come in and they match up with these, here, let me see, I think I've got a Windows box. We can throw him in the party too. So let's do another one here. Let me find one. Here, this Shenubian or whatever that is. I'll do a NS lookup for web.sheni. All right, so now this guy should actually flag as well. Now we got an NX domain, but I think this will actually flag a detection as well. So if we come over here, eventually this will populate, and this device will show as tagged. In addition to that, here now you see we have some new devices that have shown up as part of this campaign that's playing out within our environment. So here we're seeing the campaign actually play out in real time. Your SOC can come in here, get an idea of not only who matched the IOC, but what peers are they talking to. Here we have a domain controller that's talking to a database server. You know, this might be concerning as well. So we want to be able to watch the campaign play out visually, or just tell your SOC, hey, if anybody shows up in this list, go investigate the problem. And then in addition to that, we have our detections as well, right? So if you look here, we have DNS, ATI, Acute Threat Intelligence. So there we see the DNS activity that has been flagged. Here we see the flow activity, right? So even if you don't use a protocol that's earmarked in the actual threat intelligence campaign, if you just any sort of transaction with a bad IP, we're going to flag that. And then of course we see the HTTP. So again, this is an example of how to use acute threat intelligence if you have something like a feed from Recorded Future, Threat Quotient, something like that, where you can automate the download of it, or you can do it with a Jupyter Notebook and kind of run it ad hoc as you need to. You can schedule this to update periodically as well. And again, the Memcache holds about 32,000 records. If you need hundreds of thousands of records or 1 million records, then that's something that I would use the STIX formula for, where we import a STIX file into the machine. But if you have an acute situation or some sort of hand-to-hand, real-time active adversary, this is a great way to really kind of set a trap and just wait for someone to run across the tripwire. Again, this is John Smith with ExtraHop Networks. Thanks for hanging in for a long video, and I appreciate you watching. Thanks.